The anti-surge bleed air system in the Pratt & Whitney aircraft JT8D 200 series engines is designed to permit operational flexibility by minimizing the possibility of compressor surge. This is accomplished by allowing high compressor air to bleed into the fan duct during starting, low power, and snap deceleration. The basic components in the anti-surge bleed system are a pressure ratio bleed control, normally called the PRBC, a bleed valve control, 2 8th-stage bleed valves, and 1 13th-stage bleed valve. The PRBC is located on the right side of the diffuser fan duct at the 5 o'clock position. The bleed valve control is also located at the 5 o'clock position, but on the fan rear compressor case. The 2 8th-stage bleed valves are located internally on the compressor case, one at the 6 o'clock and the other at the 2 o'clock position. On the left side of the engine, the 13th stage bleed valve is located internally at the 7 o'clock position on the diffuser case. All 3 bleed valves operate simultaneously in response to a signal from the PRBC and the bleed valve control. A series of diagrams will be used to illustrate the operation of the anti-surge bleed system. The PRBC has 3 inputs from the engine: PT2, which is the total pressure at the engine inlet; PS3, discharge pressure from the low compressor; and PS4, discharge pressure from the high compressor. PS4 is used as muscle pressure to close the bleed valves. Inside the PRBC is a diaphragm and spring assembly. This assembly is mechanically connected to these 2 poppet valves. The PRBC also contains a transfer valve and these 3 atmospheric vents. As N1 speed increases, the PS3 pressure also increases. When it overcomes the combined force of PT2 and spring pressure here, the diaphragm assembly moves down, causing the poppet valves to reverse position. This action moves the transfer valve down because PS4 is now permitted to flow to the top of the valve, while the bottom is vented to atmosphere. PS4 muscle pressure is now allowed to flow to the bleed valve control. The bleed valve control is a hydro-pneumatic valve. It is actuated in one direction by spring pressure exerted here, and in the other direction by a fuel pressure signal from the fuel control unit. This signal is generated as soon as the engine is started. It is called pressure deceleration bleed override, or PDBO. When the PDBO signal is high enough to overcome the spring force, the bleed valve control translates and directs PS4 air pressure from the PRBC to the backside of the bleed valves, causing them to close. Since all 3 valves operate in the same manner and simultaneously, this drawing represents all 3 bleed valves. When the PDBO pressure is low, spring force translates the control valve and blocks off PS4 muscle pressure to the bleed valves. Internal engine pressure on the front side of the valves now causes them to open. During engine start and low power operation, PS3 air pressure is low. This allows the combined PT2 and spring force to position the poppet valves clockwise, which in turn moves the transfer valve closed. This blocks off PS4 muscle pressure to the bleed valve control. Since there is no PS4 muscle pressure being applied to the back of the anti-surge bleed valves, compressor air flowing across the valve faces forces them open. This aids in starting and provides compressor surge margin. As the engine is accelerated above idle, the increased PS3 pressure overcomes the combined force of PT2 and this spring to shuttle the poppet valves counterclockwise. This permits PS4 pressure to position the transfer valve open. And PS4 flows through the bleed valve control to the bleed valves, closing them. During normal deceleration, PS3 decreases and allows the force of PT2 and the spring to reposition the poppet valves. Now PS4 muscle pressure is cut off by the transfer valve, and compressor air forces the bleed valves open. During snap deceleration from power, there is a loss of PDBO from the fuel control. This allows the piston in the bleed valve control to translate, overriding the PRBC. Now the bleed valve control takes command of the bleed valve position by interrupting the flow of PS4 muscle pressure at this point. And all three anti-surge bleed valves open. This early opening of the bleed valves during snap deceleration helps to minimize the possibility of compressor surge. In summary, the compressor anti-surge bleed system in the Pratt & Whitney aircraft JT8D 200 series engines is normally controlled by the PRBC. During snap deceleration, the absence of the PDBO signal causes the bleed valve control to interrupt the flow of PS4 muscle pressure, and the bleed valves open. This interaction of the pressure ratio bleed control and the bleed valve control provides the 200 series engines with operational flexibility during all modes of engine operation.